lecture we were aware about some of the terms that are important. That was, we have studied what is charge, then we have studied Coulombian force, that was F, then we have studied electric field, then we have defined the potential, then we have defined what is current, then we have defined what is resistance, then we have studied the sign conventions, then we have studied law of conservation, law of energy conservation, then we have studied what is energy, what is power, and what is work done. This all we have covered in our previous lecture. In today's lecture, we will be studying what are the basic elements, what are the basic elements that are needed. If we talk about the basic elements, we will study first one. We will be studying that is active element, passive element. This is known as the active source also. Somewhere we will see that it is an active source. This is first. Then we have linear and non-linear. Then third one is unilateral and bilateral. Then fourth one we have lumped and distributed. So coming with this, we have the first slide that will be studying network element classification. We have the active and the passive, linear and non-linear. What is active element? As we have studied, active means which can provide the voltage or it can provide the current to the system. Then it is known as the active element. For example, the cell that this is the if we with the time, this is the voltage, so it is an active element. That means it is providing some voltage to it. If we talk about the solar cell, we have with the time it has the value of the current. That is, it is a active element. That means they are capable of providing a source to the load. We have two terms, that is the source and load. If this is the network, this is the V, that is a source, and this is the R, that means it is a load. So what definition we have? An element is said to be active if it can deliver the energy to the outside world for infinite time. This was the time we have taken. Otherwise passive. So examples of the active elements are the sources, that is V and I we said, and we have the passive element, that is R, L and C, because they are consuming the energy. Because they are consuming the energy, they are load. So this is the note that we have. Ohm's law is not applicable for the active elements. If V upon I ratio is positive, then it is called as passive elements, because if it is said Vi, that means if we talk about the Ohm's law was I is directly proportional to V and I is inversely proportional to 1 upon R. So this, if we relate it with the math, it will be like somewhat x is equal to y. That means if the x is varying, the y is varying, and the graph plotted with them will be something like this. It will be a straight line. So it can be I or V, or if we talk about, it will be X or it will be Y. So this is the active and the passive element. Now coming to the linear and non-linear, it is similar to this. Linear, if the characteristics of the element is straight line, as we said in this figure, we can see in the figure, the characteristic is straight line, is then passing through the origin. This is the origin, is called as the linear element, and these characteristics are constant. Non-linear elements are diode and transistor. Why diode is non-linear? Because this is the diode. So this is the diode. This is the non-linear because the if we draw the curve for this, the curve is non-linear. Now coming to the linear elements are R, L, and C. So these are the linear elements that we have. Then this is the graph that we can see that this is the graph one that gives a relationship between V and I, and we have said this is the resistance. Then we have L, then we have the capacity. So now coming to the third, that was unilateral and the bilateral. Unilateral means if this is R, the direction of the current is I. For example, this was the voltage source that we have connected, and this is the positive and negative. The current is going to flow from this resistance value. This was the R. That means if in case if I change this direction, for example, this was the polarity has been changed to this. The polarity has been changed to this. Now what will happen? Now what will happen? The current direction, or we can say the current direction across this will be changed. Earlier it was going this way, now it will be going this way because we have changed the polarity. Still the resistance is there, but the current direction is changed, but it is bilateral. That means if the direction of the source is changed, then also the current is flowing through this. What will happen if, for example, I take some other example like this? If this was the voltage source and this was the diode connected across this terminal. This was the diode, this is the positive terminal, this was the negative terminal. Let me change the. Now what will happen? This is the, we said this is positive and this is negative, the current is going to flow. And we know that the diode is what? Unilateral. Why unilateral? Because if I interchange the position, for example, now it will be converted like this. It will not work because it is a, because you all know that it do not allow to flow the current in the reverse bias. We say it only work in the positive forward bias. We say that it will work only in the forward bias, but in the diode do not work in the reverse bias. So this is the unilateral. That means it will only the current direction will flow if this is this. So in the definition we can say if an elements offer the same impedance opposite to both the direction, the flow of the current through it through is called bilateral element. Other it is a unilateral. Example, bilateral RLC unilateral element is the diode. For forward voltage, diode act as a short circuit. R is equal to 0. In reverse bias, it act as an open circuit. So R is infinite. What is open circuit and short circuited? That means if the circuit is something like this, then it is known as a short circuit. If it is like this, that means this is a voltage, the current is not flowing in this part because we said that in our previous class we said that the circuit should be closed to flow of the current, but it is open, so that's why it is known as an open circuit. So the if vi characteristic are same in direction is called as bilateral. Now coming to the lumped and distributed parameters. What is the lumped and distributed parameter? If we talk about in the real world, it is really very difficult to find the pure inductor, pure resistance, pure inductor, and the capacitor in real world. But for simplification, what we say that the if in the network analysis, these are the three resistors that are connected across this, then we calculate the what is the equivalent resistance, we can calculate it. But so the lumped elements are those elements which are very small in size and in which the simultaneous action take place. Typically, lumped elements are capacitor, resistors, and the inductor. Whereas the distributed elements are those which are not electrically separable. That means R, L, and C cannot be separated with each other. But we say that for the calculation and analysis and to understand the thing, we say that there is a pure resistive circuit, inductor, and the capacitor. So distributed elements transmission line is an example because if we draw the transmission line, we have we have resistance in that, we have inductor, and then we have the capacitor across the terminals. This is a, if it is a AC voltage, this is the trans. So these are the five terms that are used. Then we have the circuit concept, that's a resistor. We have studied what is resistance, what are the parameters. Now coming again, what to enhance that, we said it is a property of the material which oppose the flow of the electric current. Unit is ohm, L is the length, A is the area, and R, I said that the R is directly proportional to the L and inversely proportional to the area, and where rho was the resistivity of the material, and A was the area, L was the length or specific, rho is this, and the opposite of resistance is 1 upon G. This is known as the conductance. This is known as conductance. So coming forward, we have the different type of the supply. The two supply that we have, that is the AC and the DC. And in the previous class, we have defined what is AC, which have the frequency of 50 hertz, and the time period that we have said that is 1 upon 50, which means the 50 cycles are taking 1 second. Then we have the DC. Then we said that the frequency is 0. That means at the time period, it is going to remain constant. So these are the two sources that we have. This is the diagram which shows that the DC voltage, this is the AC that is pulsating. This was the time period. So let me do this one. This is the time period. What we said that the DC is the current that remain constant with the time. AC will vary simultaneously with the time, and we have studied in the what DC is more dangerous is then AC, we have studied in the last class. So the representation, this is that the voltage is in the terms of, for example, this will be the 5 volt to 100 volt, 200, 300, 500, this, whereas V is represent that V is equal to A sine omega t, and where omega is the frequency, that is 2 pi f, angular frequency is said there, T is the time period, and the frequency across this, we said in the DC it is 0, and for the AC circuit it is 1 upon T. So now coming forward, we have the Faraday law. Faraday law is in when we will be studying about the machines. The Faraday law is taking an important role. When the conductor experiences the rate of change of the flux, the EMF will be induced. That is, in this we have said that the closed path. As in our first class, we said that in the circuit the current will flow only when the circuit is closed. So the current will flow in that, and we have said that the E is directly proportional to d phi by dt. This was the magnetic lines passing. This is the phi, that is the flux per unit time, and N, then we can say E is equal to d phi by dt. This is the derivation, and the negative sign shows that the induced EMF opposes the current which can given the Lenz law. Then we have the sources. Now coming to the sources, and we said we have the two sources, that is the AC and DC, but in the DC we can classify it now in the terms of independent sources and dependent sources. So voltage and the current, these are the two: linear control, linear non-control. In our coming slide we will be studying what is this. So coming to the independent voltage source, this means they are independent, that they are not dependent. When the terminal voltage of the source is independent of the load element, this is known as the load element, that is RL. It is called as independent voltage source. Ideal voltage source is one which deliver energy to the load at the constant terminal voltage irrespective of the current load pattern. This is this was the source, IL is the load current, and this is the, then we can graph. But in the practically, if we say practical source have the internal resistance RS, we can say this is the internal resistance. If we take the internal resistance, then there will be some losses. We can say that the load resistance across. So the curve is this one. This is ideal case. This is the ideal case. This is not ideal, because we are saying that the internal resistance is there. So the graph that we can will plot will be like this. Then coming to the dependent, this was independent. Now coming to the dependent source. In the dependent source, we have current dependent current source. That means current dependent current source. This is, then we have the voltage dependent current source, voltage dependent, and this is the current. The voltage will be represented like this, and this We can say that this is positive, this is negative, or we can say the current. This will represent the current, that is dependent current. This is dependent voltage source. So in this we have seen that the current, this direction shows the current, that is the current source. Then we have voltage dependent, that means in this we can see this is GB, this is BI. Then we have the voltage dependent and voltage source, that is AB. Then we have current dependent voltage source, current dependent voltage source. Yes. So these are the few four conditions that we